Hi, welcome you all. Today we are going to learn about 3D reflection. Now you know what a reflection is. Reflection is just a mirror image of an object. And how can you obtain the mirror image? It's quite simple. Just rotate the object to 180 degrees. When you rotate an object to 180 degrees, you will get the mirror image of an object. Okay, so this is what is meant by a reflection, and whenever you try to obtain reflection of a 3D object, it becomes a 3D reflection. Okay, now let us see what are the different types of 3D reflections. Now the reflections in 3 dimension can take place on the basis of plane surfaces. There are 3 types of reflections: reflection about xy plane, reflection about YZ plane, and reflection about XZ plane. Now let us learn each of these types of reflection. First one is reflection about YZ plane. Now the reflection about YZ plane is otherwise called a reflection about X-axis. See this picture. In this picture, this is a 3-dimensional space, and in this 3-dimensional space, this is the YZ plane. Whenever a reflection is performed about the YZ plane, reflection takes place in the X-axis. I repeat, whenever the reflection is about the YZ plane, then it takes place in the x-axis. So it is also known as reflection about x-axis. So if the reflection is in YZ plane, then it is similar to reflection about x-axis. Okay, now let us see what happens when reflection takes place about x-axis. See, the object, 3D object is placed over here. When this 3D object is reflected about x-axis, then definitely the object will be reflected in this side. What is the peculiarity of this side? If this is positive x, definitely this portion will indicate negative x. So from this position, the object will be rotated to 180 degrees and the reflection of the object will be obtained at this position. Clear? I repeat, whenever you perform reflection about YZ plane, it is equivalent to performing a reflection about x-axis. When you perform a reflection about x-axis, from positive x-axis, the object will be rotated to 180 degrees and the object will naturally land up, and the reflected image will naturally land up in a space where x is negative. So from this position, after reflection, reflected image will come in this position. Okay, so how can we write the transformation equations for 3D reflection about x-axis? See, as per the figure, it is quite clear there is no change in y parameters and there is no change in z parameters even after reflection. The only parameter which undergoes change is the x parameter. That means before reflection x was positive and after reflection x becomes negative. There is no other change in other two parameters, that is y and z. So in reflection about YZ plane, y and z will not undergo any sort of change, whereas x becomes negative. So I can write these equations: x dash equals minus x, y dash equals y, and z dash equals z. Here y and z do not change, only the x becomes negative. That is, after reflection, the new x becomes negation of previous x, new y is previous y itself, new z is previous z itself. So these are the equations for reflection about YZ plane or reflection about x-axis. Let us move on to the general equation. General equation in this situation can be written as P dash is equal to mx into p, where p is the initial point. That means any point on the 3D object before reflection. P represents any point on the 3D object before reflection, and P dash represents the same point on the 3D object after reflection. So how the reflection on the how the point on the reflection object can be obtained? That means P dash can be obtained when P is multiplied with mx. Now what is this mx? Mx simply represents reflection of an object about x-axis. Clear? And reflection is similar to mirror image, so I have used the letter m over here. Clear? Now let us see how the matrix can be written. The homogeneous matrix for reflection about x-axis can be written as, this represents P dash and this represents P, and we need to find the value of mx. So what should be the value of mx such that when mx is multiplied by p, you will get the value of p dash. As I have already told you in previous videos, whenever you multiply each row of transformation matrix with the column matrix, you will get the values of x dash, y dash, z dash and 1. So when first row gets multiplied with the column matrix, you will get the value of x dash. When second row of mx gets multiplied with column matrix or p, you will get the value of y dash. When the third row of mx gets multiplied with p, you will get the value of z dash, and similarly when the fourth row of mx gets multiplied by p, you will get the value of 1. So let us write the matrix. There is a shortcut method of writing the matrix. What you have to do is just you try to write the unit matrix. So remember, this is a square matrix. What is the meaning of a square matrix? Square matrix means number of rows and columns are equal, and I am going to write a unit matrix. What does this mean? What is a unit matrix? Unit matrix is a matrix in which all the diagonal elements are 1 and all other elements are 0. I repeat, all the diagonal elements are 1 and all other elements are 0. Such a matrix is called a unit matrix. So first let us write the unit matrix. So I am going to write 1, 0, 0, 0. Second row 0, 1, 0, 0. Third row 0, 0, 1, 0. Fourth row 0, 0, 0 and 1. So here I have written a square matrix which is a unit matrix. Now what does the equation say? Equation says the value that I must get is x dash equal to minus x, y dash equal to y, z dash equal to z and 1 equal to 1. This is the equation that I need. So here when I try to multiply the first row with column matrix, the equation which I get is x dash equal to x. But what do I need? I need x dash equal to minus x. So to get minus x, x should be multiplied to minus 1. So instead of 1, I am putting a minus over here. There is no other change. Now let us multiply. Minus 1 into x plus 0 into y plus 0 into z plus 0 into 1. What is the result? You will get x dash equal to minus x. What about the second equation? Second equation is y dash equal to y. That means y should be multiplied by 1 and all other terms should be multiplied by 0. So at position of y, I have written a 1 and all other positions will be having a 0 in it, such that when second row is multiplied by column matrix, you will get the value of y dash as y dash equal to y. What about the third equation? Is z dash equal to z. Only the z should be multiplied by 1. There are no other terms in this equation, so all other terms will be represented as 0. So only z is multiplied by 1 and all other terms are multiplied by 0. So except z, all others are zeros. So that the equation we get is z dash is equal to 0 into x plus 0 into y plus 1 into z plus 0 into 1. What about the last term? I must get 1 equal to 1. That means there are no parameters related to x, y and z. So all positions associated with x, y and 0 will be x, y and z will be 0. That means x, y and z, all these three should be multiplied by 0 except this term. Last term should be multiplied by 1. So when you multiply the last row with column matrix, you will get the value 1 equal to 1. Okay, so this is how reflection about xy plane or reflection about the x-axis is achieved. Now let us proceed to the second type of reflection, which is reflection about xy plane. As we have already explained, reflection about xy plane means reflection takes place in the xy plane, or we can say reflection takes place in z-axis. And since the reflection takes place in z-axis, after reflection positive z will become negative z, but there will not be any change in x and y parameters. I repeat, since the reflection is taking place in YZ plane, no change will occur to x and y values. That means even after reflection, x will not undergo any change and y will not undergo any change. But since it is a reflection about z-axis, z will undergo a change. That means after reflection, z will become negative. Let us see how it happens. This is a three-dimensional space with three axes x, y and z, and since the reflection is going to occur in xy plane, that means this is the plane in which reflection is going to occur. So as per the equations, x and y will not undergo any change. So I can write after reflection the new x will be equal to previous x, and after reflection the new y will be equal to the previous y. But since it is a reflection about z-axis, after reflection z will become negative for the reflected image. That means from this position object will be reflected to this position. That means this portion represents an z with negative value, whereas this portion resembles position where z is positive. Okay, so before reflection we were having an x, y and z where z was having a positive value, and after reflection we will have same x and y values for the reflected image, only the z values of the reflected image will be negative. So we can write the equation as z dash, that is new value of z will become negative z. Proceeding to the general equation, we can write p dash is equal to mz into p, which means when the initial point is multiplied by a matrix mz, you will get the point p dash, or we can say when the initial point is reflected about z-axis, you will get the point p dash. Now m represents mirror image or mirror reflection, and z represents its reflection about z-axis or a reflection about xy plane. Now I am going to write the matrix, homogeneous matrix for this corresponding reflection. As I already told you, this column matrix represents matrix for p dash and this represents the matrix for p. What I wish to write is matrix for mz, reflection about z-axis. Now since this is a reflection about z-axis, what is the change do I wish to observe? Only the z changes to negative. There is no change in other two parameters. So again I am going to write a square matrix, which is a unit matrix. So let me write it 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. So I have written a square unit matrix such that when the first row is multiplied to matrix P, you will get x dash, when second row of mz is multiplied to p, you will get value of y dash. When third row of mz is multiplied to p, you will get z dash, and when fourth row of mz is multiplied to p, you will get 1. So these are the equations that I want. I want x dash equal to x, y dash equal to y, z dash equal to minus z, and 1 equal to 1. What are the changes that I observe? To get the first equation, there are no values related to y and z. Only there is an x value, and since it is a positive value, x should be multiplied to 1. So only x is multiplied to 1, all other values are written as 0. When we take the second equation, it is y dash equal to y. That means there are no parameters related to x and z. Only y is there. So to get y as the answer, y should be multiplied to 1 and all other terms should be multiplied to 0. So except y, all other terms will be multiplied to 0. That is 0 into x plus 1 into y plus 0 into z plus 0 into 1. Clear? Now there comes the third equation. Equation is z dash equal to minus z. That means no terms related to x, y. So both x and y should be multiplied to 0. But z dash is equal to minus z. That means z should be multiplied to minus 1. So I am putting a minus over here, such that when I multiply the third row with p, I will get the equation z dash equal to minus z. Like this, 0 into x plus 0 into y plus minus 1 into z plus 0 into 1. In this way, when you multiply these two, you will get the value z dash equal to minus z. And to get the last equation 1 equal to 1, there are no parameters related to x, y and z. So x, y and z, all three will be multiplied to 0, except the last term. Last term should be multiplied to 1. And we will get the equation 1 equal to 1. So this is how we write the equation and the corresponding homogeneous coordinates or homogeneous matrix. So let us now proceed to the third type of reflection, which is reflection about y-axis or reflection about xz plane. Remember, we are performing a reflection about xz plane. That means there are no change to the parameters x and z even after reflection. So the value that x and z occupy before reflection will retain even after reflection. No change in x and z parameters, but since it is a reflection about y-axis, after reflection the y parameter changes to negative. So clearly we can write the equations as like this: x dash equal to x, which means no change in x even after reflection. Y dash equal to minus y, that means y changes to negative after reflection. Z dash equal to z, which means z is also not going to change even after reflection. So x and z will not change, but y will go to negation. Okay, that means initially a three-dimensional space is given to you with an object like this. It's a 3D object. After reflection, the reflection takes place about y-axis. That means this is how the object is going to reflect. Sorry. This is not the direction. This is the direction. This is how the object is going to reflect. So after reflection, from this position, the object will be reflected at bottom position. That means a position where y is negative. Okay, so from initial position, object will be reflected and the reflected image will appear here. When the reflected image appears at the new position, what is the peculiarity of that position? There is no change in x and z, but y becomes negative. Since at this position y was positive, after reflection y becomes negative. This is how reflection takes place about y-axis. Let us move on to general equation can be written as P dash equal to my into P, which means initial point when reflected about y-axis, P dash can be obtained. That means new point can be obtained when initial point is reflected about y-axis. Now, as we did earlier, we are going to write the homogeneous matrix, and we already know the matrix values of P dash and P. We are going to write the matrix related to my. So this is a square matrix. I am going to write a unit matrix. So the values of the unit matrix are 1 0 0 0 1 0 0 0 0 1 0 and 0 0 0 1. So I have written the unit matrix. One more thing I have to do, since y dash equal to minus y, second row, second element will become minus. Now let us multiply. I am going to multiply the first row with the column matrix. It becomes 1 into x plus 0 into y plus 0 into z plus 0 into 1, which gives you x dash equal to x, which means x is multiplied to 1 and all other terms are multiplied to 0. And the equation which I will get is x dash equal to x. Okay, now let us multiply second row with this column matrix. That means 0 into x plus minus y into 0 into x plus minus 1 into y plus 0 into z plus 0 into 1. That means you will get the equation y dash equal to minus y, where only y is multiplied to minus 1 and all other terms are multiplied to 0. Now comes the third row. Third row, except z, all other terms are multiplied to 0 and z is multiplied to 1. Like this, 0 into x plus 0 into y plus 1 into z plus 0 into 1. So what is the value you will get? You will get z dash is equal to z. What about the last row? Except 1, all other terms will be multiplied to 0. That is, x is multiplied to 0, y is multiplied to 0, z is multiplied to 0, except 1. 1 will be multiplied to 1 to get 1. So the last equation which we will get is 1 equal to 1. So in this way you can obtain 3 different transformation equations for reflection. First one was reflection about x-axis, where only x becomes negative and all other terms are positive. Second was reflection about y-axis. When reflection about y-axis occurs, in the reflected image only y becomes negative and all other terms, that is x and z, will still remain positive. It will remain the same value itself. Coming to the last one, reflection about z-axis. This is the reflection where z becomes negative after reflection, and the other two terms, that is x and y, will still be the same. So in this way, 3 different types of reflections in 3D can be achieved. Hope you have understood the concepts in 3D reflection. Maybe these concepts have been made easy for you. I think this session had helped you a lot. Keep watching the videos. Support me. Thank you.